Hey there, let's talk about all the incredible changes happening around us every single second. From an ice cube melting in your drink to a piece of wood burning in a campfire. They seem super different, right? Or are they? Let's dive in and find out. So, you've got ice turning to water, a banana getting all brown and mushy, and a candle's flame just dancing away. These things are happening all the time. But is there a way to, sort them into different groups? What's the real secret behind what makes them different? That's what we're going to investigate. All right, first up, changes in appearance, or what we call physical changes. This is all about when something looks different, but deep down, it's still made of the exact same stuff. Okay, let's do a little thought experiment. Imagine you've got a plain sheet of paper. Now, fold it up into a super cool paper airplane. It looks totally different now, doesn't it? It's gone from a flat rectangle to something with wings. But now, what happens when you unfold that airplane? Yeah, it's got some creases in it for sure, but is it still paper, or did you magically turn it into something else entirely? Yep, it is absolutely still paper. All you did was change its shape. Nothing new was actually made. It's the same idea as crushing a piece of chalk into a powder. It looks way different, but it's still 100% chalk. And that right there is the key to what we call a physical change. It's all about changing those physical properties, things like its shape, its size, or even its state, like a solid turning into a liquid. The most important part? No new substance is ever formed. Okay, so we've got physical changes down pat. But what about when a change creates something completely new? Now this is where the real fun begins. Let's talk about chemical changes. All right, time for a classic kitchen experiment. Maybe get an adult to help with this one. If you take some vinegar and add a little baking soda, what do you think is going to happen? Any predictions? Whoa, you get that awesome fizzing and bubbling. You can literally hear the reaction happening. All those bubbles mean one thing for sure. A gas is being made right before your eyes. But hold on a second. Is that gas just like trapped air escaping? Or is it a brand new substance that literally didn't exist a few seconds ago? How would we even know for sure? Well, it turns out that gas is actually carbon dioxide. A totally new substance was created from that reaction. And think about it, there's no undo button here. You can't just unfizz the mixture to get your vinegar and baking soda back. That's a huge clue. And that is a perfect example of a chemical change. It's when the original substances actually react and transform into something completely new with completely different properties. It's not just a makeover, it's a whole new identity. Okay, now this is where it gets really interesting. What if I told you that sometimes a physical and a chemical change can happen at the exact same time in the same object? For that, let's take a closer look at a burning candle. So when a candle burns, you see the solid wax melting near the flame, right? It turns into a little liquid pool. That's a physical change. It's still wax, just melty. It can even drip down the side and turn back into a solid. But what about the flame itself? That flame is burning the wick and the wax vapor, and that is a chemical change because it's creating all sorts of new stuff: smoke, heat, light, and gases we can't even see. So let's lock in this main difference. With a physical change, no new substance is formed, and you can usually reverse it. Think about melting ice. You can always refreeze the water. But with a chemical change, you get totally new substances, and it's almost always a one-way trip. You can't unburn a piece of wood and turn all that ash back into a log, can you? So why does any of this matter outside of a science class? Well, because understanding these two types of changes helps us make sense of the world all around us, from what's happening in our kitchens to the entire planet itself. I mean, just think about it. That rusty spot on an old bike? Chemical change. The bonfire you love to sit around? Chemical change. Cooking an egg from a runny liquid to a firm solid? You guessed it, chemical change. Even that banana on the counter slowly turning sweet and yellow? That's chemistry in action. And nature has some of the coolest examples. Have you ever seen a firefly light up? That incredible glow isn't a tiny light bulb. It's a beautiful chemical reaction happening inside its body called bioluminescence. And physical changes can be huge. I'm talking planet-sized. Over thousands of years, wind and ice break down giant mountains into tiny grains of sand. That's a physical change called weathering. And when rivers carve out massive canyons, that's just erosion, another giant physical change, constantly reshaping our world. So, you see, from the tiny chemical reaction that makes a firefly glow to the massive physical force that carves a canyon, these two types of changes are basically the engine of our world. Once you know what to look for, you'll start seeing them everywhere. All right, I'll leave you with this final thought. Think about the lunch you ate. When you chew your food, you're breaking it into smaller pieces. That sounds like a physical change, right? But what happens once it gets to your stomach? Is your body just rearranging it? Or is it performing a ton of chemical changes to get energy from it? Maybe it's both. Definitely something to chew on.